what we begin to look for in this 7.5 is we look at what's called partial fractions. And what we do is we try to break an integral up into its factored pieces. So to begin kind of explaining what this is, I'm just going to give you kind of an example that they had in the book. So like you know from algebra, if you're getting a common denominator, like if you're adding two fractions, well, what do? If you were doing this problem, I'm just going to do it at the side. You don't need to write this down though. Just pay attention to it if you want to. Okay, so this one is, if you got a common denominator, you'd multiply by x plus 4 over x plus 4. And then over here, you'd multiply by x minus 2 times x minus 2. Well, if you went through and put the details together on that, and I've kind of showed you what you would do here, if you went through and did all that, you would get this. If you multiplied that numerator out, notice you would have x plus 4 plus 2x minus 4. 4's cross out, so you'd have 3x. Now that's what you're kind of used to doing in algebra, is getting common denominators and putting things together. Something that you've never done before probably is start this way and then go back to the beginning. So you can kind of decompose the final answer into the original problem where you're summing two fractions together, or more than two fractions like that. So we call that partial fraction decomposition. There's three parts of this. So what you kind of look at with this is if you had a function like this, and we've looked at functions like this before, a lot of times we did completing the square. Well, partial fractions is a different approach to this type of problem, and you'll probably like it better. So the idea is, if you were doing this, that's a fairly difficult thing to integrate because you'd probably have to use substitution. You might have to do completing the square. What we can do is we can break this up into where it came from. So you can basically change that to 1 over x minus 2 plus 2 over x plus 4. Now, do you guys agree that this is an easy integral to do?
Yeah.
Okay, because if you did this integral right there, what is that? ln x minus 2, right? Okay, what's the next one? 2 ln x plus 4 plus c. So basically, if you can convert this to this decomposed form, then it turns out to be a real easy integral to do. So the big part of this problem is the algebra of the decomposition, and then once you get that done, the integrals are going to be easy. Okay, so partial fractions is not too hard to do. It is kind of messy. It's got a lot of algebra in it. So let's go through. And what I'm going to do is I'm going to show you how to decompose this thing into 1 over x minus 2 plus 2 over x plus 4. Okay, so here's the idea, is we know that the two fractions, the denominators, are x minus 2 and x plus 4. What I do is I just use those two variables a and b. And what I'm going to do is we're going to solve this equation. We're going to try to find what a and b are and do that. So to start with, what you need to do on your paper is you just need to write the left side down and then kind of spread this out a little bit, because we're going to get rid of fractions basically when we do this. So just kind of spread your work out when you're doing this. So you want to get this set up. Now this is an equation that's got fractions, right? If you have an equation with fractions, what do you generally do? You generally get rid of fractions, right? So what I'm going to do is I'll have you multiply everything by x minus 2 over x plus 4 over 1, because you're trying to get rid of all these fractions. And if we do this, we'll cancel a lot of stuff out, and then we'll kind of see what we're left with here. Okay, so we want to do that. Well, let's go ahead and cancel things out. Then what we want to do is write whatever we're left with. To me, the key to doing this, when you practice this, you start doing this a little bit more in your head, but everything's going to cancel out there. The x minus 2's cross out there, and the x plus 4's cross out there. So what you're left with is a 3x, and then an a and an x plus 4, and a b and an x minus 2 like that. And then we're going to write that down, and then we'll have enough information to figure out what a and b is. So after you do that, you're going to get 3x is equal to a times x plus 4 plus b times x minus 2, like that. And our job on this problem is to find a and b. Okay, you with me so far? Okay. Now, what we're going to do with this, we're going to go ahead and multiply everything out on the right side. So we'll have 3x, and you want to go ahead and do a distributive property, so that's going to be ax plus 4a there. Okay, then go ahead and do a distributive property here. So that's going to be plus bx minus 2b, like that. And then we're going to kind of rearrange this. We equate these coefficients. So here's the part that you got to pay the most attention to, because what I've done there is just kind of basic algebra. So what I'm going to do is write the 3x down, and then everything that has a x in it, I'm going to group those together. So I'm going to write ax plus bx, those go together, and then the things that don't have an x in it just go together like this. So I'm going to write that as plus 4a minus 2b, like this. And you end up getting a system of equations that will allow you to figure out a and b. So I'm going to do one more thing here. I'm going to have you factor the x out of this, just out of that, so you'll have x, a plus b, and then just plus 4a minus 2b, like that. Now, I'm going to have you write maybe this down like this, because maybe you'll see this a little bit better. Let's just write that as 3x plus 0, like this. Okay, now here's the idea. You're equating things that are equal to each other. So if you look at this, okay, that's got an x, that's got an x. Is it logical to you that a plus b has got to be 3? Because that's an x, right? Just ignore that for a minute. Isn't a plus b going to have to be 3? Yeah, okay. How about 4a minus 2b? That's got to be that. Okay, it's got to. Okay, what you're going to end up having is whatever is with x is going to be equal to the coefficient of that. Those don't have variables, so they got to be equal to 0. So what you're going to have is you're going to have a system of equations. You got 2 equations and 2 unknowns. So what you solve now is you solve this system. So we're going to have a plus b is equal to 3. So again, this thing right here has to be that. It can't be anything else. And then this thing right here has to be 0. So you would have the second equation, 4a minus 2b is equal to 0. Now you got to go back and you got to dig into your background. You maybe haven't done system of equations in a long time. You do this in intermediate algebra, a little bit in college algebra, but not too much. So let me just kind of remind you of how you do this. You can do elimination, you can do substitution. The way I'm going to do this is I want the b's to go away. I want them to cancel. So if that's a negative 2b, I would like this b above to become 2b. So what I'm going to have you do is let's multiply the top equation by 2, both sides by 2, and then that'll eliminate. This is called elimination method. So you can see this and let me know if you don't remember this. So that's going to be 2a plus 2b on that side when you distribute equals 6. Then I'm going to leave the second equation alone like that. Does that look familiar, like something you've done at some point in your life?
Can you explain that again? The 2 times
Why, multiplied by 2? Okay, the idea is when you're doing this is when you have a system of equations, 2 equations and 2 unknowns, you're wanting one of those to cancel out. So I just noticed that that was a negative 2. If I can make that a 2, when I add the equations together, they're going to cancel out. Now see, that's what I'm going to do in the next step. That cancels, right? What are you left with? 6a equals 6. And you can solve the equation 6a equals 6. Does that look familiar? Algebra background stuff. Like I say, Calc 2, everything comes together. You start doing all this stuff you've learned in the past, just shows up in different places. So that's 6a is equal to 6, and then you can do that in your head. You can divide by 6, you get a equals 1. Okay, so we got that. Okay, now we got to find b. Well, we have the equation a plus b is equal to 3. That was our original equation in our system. So if a is 1, and you can do this in your head, 1 plus b is equal to 3. Tell me what b is. It's 2. Okay, So what we've done by doing this, see, the idea is if you go back here now, see, A is 1, B is 2, so that means that this expression is the same thing as 1 over x minus 2 plus 2 over x plus 4. And you can tell you're right, because if you just get a common denominator and put those together, it should take you back to the beginning where you have 3x over x minus 2x plus 4. So that's the process that you would go through and do of partial fraction decomposition. That's the big part of the problem. Once you have that done, then most of the time it's pretty easy to integrate the result, so there wouldn't be a big deal in integrating that. Okay? So tell me if you get a gist of what I'm doing there. Okay? What you're trying to do is break that up into a sum of two fractions, because it makes the integration easier. Okay? Any question on anything there? We're going to do this a bunch today with lots of different examples. I'll show you a few shortcuts. In time, you get to a point where you can do your systems pretty quickly on these things, and there will be a few little tricks and shortcuts that you come across them. All right? So what I want to do next is kind of define on the next page what we're trying to do, and then we'll do a complete problem. I just wanted to show you the decomposition method there. Okay, everybody with me? Okay. Okay. So the key thing is those systems of equations. Now, if I go to the next page here, we're going to look at three situations. So we're going to look at what we call simple linear factors. Now, what this is saying is what I just did on the previous page with simple linear factors. If you end up factoring something like this, you just break it up into A over the first factor plus B over the second factor. If there was a third factor, you would add in a C over that and so forth. And that's if the factors are different. If they repeat, then it's a little bit different situation. Okay, so what this is really saying, and all this language here, is it's just saying if you had, and you can write this down as an example if you want to. I think it's probably decent to write something down like this. If you had something like 1 over x minus 2, I'm just making this up, x plus 3, x plus 4, then your partial fraction decomposition would be set up like this. You would say a over x minus 2 plus b over x plus 3 plus c over x plus 4. Now, if you had more and more factors, then what you would do is you would just do that repeatedly from then on out. Now, you're not going to probably do more than 2 or 3 factors. Typically is about as much as you're going to do, because it gets pretty hairy if you get into a whole bunch of factors. Okay, so what we're going to do is I'm going to go ahead and do this integral using this partial fraction decomposition technique. So the first thing that you want to do, you want to kind of get out of the mode of completing the square. That looks like a completing the square problem. What we're going to do is just factor this. And by the way, the completing the square problems I gave you, usually they didn't factor. So that's why we went to completing the square, and they were set up a certain way. So what you want to do, first of all, go ahead and factor the denominator. Okay, this should factor. That's going to be x and x, and let's see, the two numbers that multiply to give 24 that add up to 2 are going to be 12 and 2 with a, hold on, no, that's, no, 4 and 6. 12 and 2, yeah, 4 and 6. Let's go 4 and 6. Okay, so it's going to go like this. We're going to go 4 and 6. Then we'd have to have the minus with the 6. Then we'd have the plus like that. So that's how the factoring goes, is like that. Now, before we even, think about doing the integral, since everything factored nicely, what we're going to go ahead and now do is we're just going to do the partial fraction decomposition. Okay, so we got everything factored correctly. So what you want to write on your paper, and when you do this decomposition, you want to go ahead and write down, don't even worry about the integral, we're not there until the very end of the problem. We got everything factored out kind of nicely. You want to spread out the work on your paper, okay, like this. Then what you're going to have is you're going to have a over x plus 4, then have a little room, and then you'll have b over x minus 6 like that. So we're going to do this one similar to the last example, okay? All right, now what do? You get rid of your fractions. So this is an equation we built here. Our ultimate goal is to find a and b. So what you're going to do is you're going to multiply both sides of this equation. You want to multiply every piece by x plus 4x minus 6 over 1. So you want to do the same thing here. You can get to a point when you practice this where you'll be able to kind of handle this in your head, because all you're doing is just canceling things out anyway. But as I teach this, I'm going to write that out real carefully. Okay. Now what you want to do is cancel and write down what you're left with. Okay, so you always want to get rid of your fractions, so we're going to be left with 10x here, and then we have a times x minus 6 plus b times x plus 4, like that. Okay, everybody with me on that? Okay, not doing any algebra, we're just doing, or calculus, we're doing algebra. Okay, now you'll be able, and as I go through this a little bit further, I'll skip a few steps, but for now I want to just kind of carefully write everything out. So here we have ax minus 6a, like that, just distributing that out. And then over here you want to have bx plus 4b, like that. Okay? Now what you end up doing is you put the x's together and the things that don't have x's together like this. So I'm going to write this as 10x plus 0, like that. Then I'm going to put together the ax and the b. And then I'm going to put together just the a and the 4b, like that. So I'll put that together like that. Okay, again, if there's a few things you feel comfortable with skipping a step on, that's fine. Okay, because what you're trying to do with all this work right here is build your system of equations. So this is 10x plus 0. Factor the x out of there, so you'll have x times a plus b plus negative 6a plus 4b, like that. So that's the idea. Now with a little practice, you can get to this point right here. I think, usually at this stage, students can kind of get to the point where they do this in their head. This is what I do. I just kind of look at, I have an x, I have an a plus b. Okay, then I have a negative 6x and a 4b. So you can jump all the way down there if you want to. Okay? Now here's what I want you to see. What does a plus b have to be equal to in this equation? It has to be 10, right? Because that's got an x. That matches. That has to be 10. A plus b has got to be 10. What does this have to be equal to? 0. Okay? If that thing is 0 and that thing is 10, then you've got an equation that's got to be true. So your system is what you want to get set up. You get to that point right there so you can get your system of equations put together. So your system is going to go like this. This is equal to that, and this is equal to that then. So that's your system of equations. So let's write that down. Let's see what we get. We got a plus b equals 10. Then we have negative 6a plus 4b is equal to 0. So you got to solve that system of equations. You can do substitution. Elimination is what I do most of the time. Okay? If you get into more advanced mathematics, once you start learning linear algebra and stuff like that, you start dealing with matrices more. Okay? Because then you can do it with technology. Okay, so what I'm going to do this time, and it's your call, I'm going to make the decision that I'm going to make the a's cross out. So what should I do to the top equation if I want the a's to cross out? Multiply by 6. Good. Okay, so let's take the top equation and let's multiply both sides of that top equation by 6. Okay, and then what I'm going to do is just leave the second equation alone. So I have negative 6a plus 4b equals 0, like that. Okay, so what that's going to leave me then with is 6a plus 6b equals 60. Then I have negative 6a plus 4b is equal to 0. Now the a's cross out. So that's going to leave me with 10b equals 60. So what is b? B is 6. Okay, so we got that. Okay. Now you'll be able to do a lot of stuff in your head on this now. So now go to your first equation is just a plus b equals 10. So if a plus b is equal to 10 and b is equal to 6, then what do you have? You have a plus 6 is 10. So in your head, what's a? 4. Okay, that's what the whole key of the problem is to figure out what a and b are then. Okay, that's all algebra. So it took us a bunch of steps just to get down that algebra. Okay, does that look okay? Okay, now we're ready now to do the calculus. So what we're going to do is I'm going to just start by writing down the integral in the factored form. So we have 10x over x plus 4, x minus 6 dx. Okay, now remember the way this went was like this. Okay, we started off with this, a over x plus 4 and b over x minus 6. So that means a is 4, so we're going to plug that a in, make that a 4, and then we have x plus 4. Okay, the second part was x minus 6. With b turned out to be 6. So what we're doing is we're changing this integral to that integral right there. Okay, and then we're ready to do the integral. Okay, does that look okay? Now, you'll be able to do this in your head because technically what you're doing when you do these integrals, now I'm going to write this step out. You don't have to write this step out when you're doing these problems because you can do the integral in your head at the end, but really you're doing this and then you'll have your integrals put together. Okay, so you should be able to do this integral in your head. What's that integral? ln of what? X plus 4, good. Okay, that is an ln integral. You don't have to do use substitution on that, and you can check that pretty easily like that. So that's what you get. Okay, and then the next one, what you'd have is the 6 comes down, and then this integral right here, same idea, isn't it? That's going to be ln of absolute value of x minus 6 plus c like that. Okay, which is an okay answer. There's a few other things you can do just with properties of logs. Okay, so does everybody follow that okay? What I've done. Okay, now if you're dealing with logarithms, remember you can bring the 4 up, you can bring the 6 up. We're just going to do a couple of log properties. We'd end up having ln x plus 4 to the 4th plus ln of x minus 6 to the 6th plus c. Now, how do you write the two logs together if they're a sum? Multiplication, exactly. That's college algebra stuff. So you could have ln of x plus 4 to the 4th times x minus 6 to the 6th plus c like that. And then the other thing that you can do on this too is realistically on this problem, this is an even exponent. Now there's a reason why we have the absolute value is because you can only do a log of a positive number. But what happens if you take any number to the even powered? What do you get? Positive. So since they're both even exponents, okay, you would want to go ahead and not write your answer this way. You would just go ahead and write it this way. You just write it as ln x plus 4 to the 4th times x minus 6 to the 6th plus c. Okay, and that's the way you would want to write your answer. You want to pay attention to those odd and even exponents. If they're odd, you got to leave it alone in the absolute value because you don't know what x is. But in this case, you can just leave that alone. Okay, so that's the answer to the problem. Okay, and most of the work on that is doing the partial fraction decomposition to find a and b. Once you got that, it's easy. You see what I mean? Okay, does that look reasonable to everybody? Okay, usually students do pretty well with partial fractions. They get a little heavier than this, but that's kind of a straightforward starting point on that. And we're going to look at the different cases on this. So that's what we call a simple linear factor. Okay, so let's see. The next one, I'm going to do one more like this one. This one has got a little more involved, but it's still the same idea. Okay, so I'm going to have you start this one off we need to go ahead and focus on factoring the denominator. I'm not going to worry about the numerator. That doesn't have anything to do with the first step. All right, so how do you factor the denominator? What do you notice? It's got a z, right? You want to take a z out. So we're going to have z times z squared plus 4z minus 5 dz, and then it's going to factor further, okay? And we're looking at the situation where they factor. If they don't factor, you got to do something totally different, and we'll get there. So the next step I'm going to write is z squared plus 20z minus 15, and then it looks like we can factor this piece right here. That should be a factorable trinomial, so that's going to be z times z, 5 times 1, and a plus and minus like that, okay? Now I hope you would have, and that shouldn't be a dx, that should be a dz. One thing is, if you factor something, man, as long as these problems are, don't you think it's important to just make sure you factored right so that you don't waste any time? Yeah, okay, I see students do it all the time. Don't waste time. Make sure that you factored that right, okay? Now, what we're going to do is we're now going to do our partial fraction decomposition. So we're going to get away from the calculus for a bit here. And you want to write this like this. You want to just do the z squared plus 20z minus 15 over the factors, which are 0, or z plus 5, z minus 1. You want to spread out on your paper a lot. Now what you're going to do is these are different factors. We call these simple linear factors. Why linear? Because they're linear, right? Mx plus b. They've got a linear structure to it. So what we say is we say a over z, that's your first factor. Then you say plus b over z plus 5. And then you say plus c over z minus 1 like that. All right, so what I'm going to do, and I'm going to show the step on here, and when you're doing your homework, as long as you know what you're doing and how things cancel, you can do this in your head if you're kind of cautious about how you do this. And I'm going to write everything out cleanly and kind of clearly when I do this for now, so that you get the idea of how things cancel. So it's a little pain to do this, but I'm going to do it. All right, so I think I got everything in here. Now it's just kind of a matter of getting everything to cancel correctly. And then we're going to write what we have left here, okay? So what you're going to have is, of course, everything cancels on the first one. So you're going to be left with z to the second plus 20z minus 15 like that. Okay, the next one is the z's that cross out. So you're going to be left with a times z plus 5 times z minus 1. Okay, go to the next one. It's the z plus 5s that cancel. So you've got b times z times z minus 1. Then over here it's the z minus 1 that cancels. So you're going to have that like that. Okay. Now what I'm going to show you on this problem is it's kind of nice to begin to see some tricks on this. Now you can multiply this out. I'm going to multiply it out, but then I'm going to show you a kind of a nice little slick trick on this one in just a minute here. But let's go ahead and just multiply everything on the right side out. I think you're probably less likely to make mistakes if you do that. So what I'm going to do is we're going to FOIL this. We're going to multiply that. We're going to multiply that. Okay, so let's just go ahead and do that. So if you FOIL this out, you can do that all in your head. That is z squared plus 4z minus 5. Okay, and this next one's going to be b times z squared minus z. And this is going to be c times z squared plus 5z like that. Okay? Now, what we're going to try to do is we're going to try to rearrange everything here. Now, I'm going to kind of try to get you to do this now so you don't have to write as many steps. There's a couple of approaches on this. See, what you can do is your job is to put all the z squareds together. So you could write down, without multiplying all that out unless you need to, you could just say az squared plus bz squared plus cz squared, right? And then all the z's. You would have a times 4z, b times negative z, and then c times 5z. You can just kind of do that all in your head if you want to, but if you need to just write everything out and rearrange later, you can do that too. So I'm going to go ahead and skip one step and just see if you follow what I'm doing here. So what I'm going to do is I'm going to put all of the z squareds together. Okay, so these are my z squareds, and I'm going to have it already in a factored form. So I have z squared times a plus b plus c. Okay, that takes care of that. You might as well just go ahead and factor it and do that. Okay, now what I'm going to do is all the z's. So for the z's, I've got that, that, and that. So I put that together. I'm going to have plus z. I'm going to have that factored out. And notice that what I have is 4a there. Then I have minus b. Now that's going to be a negative b if you distribute that. So that's minus b. And then I have plus 5c like that. So that puts all that together. Okay, does that look okay? That's one of your goals, is you want to try to be able to do that, you know, reasonably in your head. Now the last thing that we need to do is we do have one thing left over on this now. And if you look at your basic terms on this, it looks like you also have a 5a kind of like that then. Okay, so this thing right here is its own term. So what I'm going to put on that is we'll just put a minus 5a. Okay, let me pause there for a second and see if you guys were able to follow what I did in my head. Because I'm confident you'd be able to get this okay if you multiplied everything out. I just look at a plus b plus c. Those are all the z squares. Okay? Then the z's go like this. I have a 4a, I have a minus b, and then I have a 5c. Is that reasonable to everybody? Okay? Now, here's what you want to do in your head. The reason we write it this way is because what does a plus b plus c have to be equal to by looking at that side? It has to be whatever's in front of that, right? That's got to be 1. What does this thing, 4a minus b plus 5c, have to be equal to? 20. What does negative 5a have to be equal to? 15. Okay, yes?
Just didn't understand the negative 5a, because it has to be negative 5c.
This part?
Yeah.
Okay, that just came from here, and I don't have any, everything else has a variable in it. Negative 5a, everything else has a variable, so that's just kind of left over.
Oh.
Okay, if you multiply it out, if you need to multiply that out before, you know, doing that in your head, you can, and you would see that you'd have a 5a left over. Okay, so what we want to do from here then is you want to put your system together. So this thing has to be equal to 1. We know that. And then this thing right here has to be equal to 20. And then that leaves us with this thing has to be equal to that. So our system of equations on this goes like this. We would have a plus b plus c equals 1. We would have 4a minus b plus 5c is equal to 20. And then we would have negative 5a is equal to negative 15. And your job is to find a, b, and c. Once we do that, we'll be able to do the integral very easily. Okay? So here's what I notice on this. First thing I notice is if you have negative 5a equals negative 15, well, you can solve that. Okay, you can divide both sides by negative 5. Well, that's going to be a equals 3. Okay, so that's the first key piece we need, is we need that. Okay, now what I can do now is I can plug this in to these two equations. So I'm going to take these two equations, and where I see an a, I'm just going to replace it with a 3. So what I'll have here is that top equation, I'm going to have 3 plus b plus c equals 1. The second equation, I'm going to have 4 times 3 minus b plus 5c equals 20. Once I know one variable, I just start plugging it in, and I get a new system. Okay, so what I have from here, and you know, see if you can do this kind of in your head with me. This is b plus c equals negative 2. Okay, because what did I do? I just moved the 3 the other side. 1 minus 3 is negative 2, right? Okay. Now the next one would go like this. You would have negative b plus 5c. And see, now you have 20 minus 12. So that's equal to 8 like that. So then you would end up having that system of equations right there. All right, so we've got a okay. We've got a equals 3. Now, how do you solve this system right here? That's an easy one to solve. The b's already cancel out, don't they? Okay, which is kind of nice. So if we just take that now, add the terms together, that cancels. That's going to be 6c is equal to 6. And then that means in your head you'd get c equals 1, right? Okay. And then your last thing is, well, you got this equation right here. You got to kind of keep track of all these equations. Well, now that we know what c is, we would just have b plus c, which is 1, equals negative 2. So that means that b is equal to negative 2 minus 1. So b is equal to negative 3. So all that work with the partial fraction decomposition is finding a, b, and c. Okay? You guys got any questions? Good. A lot of work, isn't it? It's not hard. There's a lot of algebra going on in those systems of equations. Now I'm going to show you, we're going to go ahead and finish the integral, but I'm going to show you a little trick on this problem too, because you want to be aware of this trick when it shows up. Saves you a little bit of time. So here's basically what we have. If you go back, I'm going to highlight these things right here kind of in blue. This is the partial fraction decomposition right there. That's what our integral is going to become. So a over z, a was 3, so this thing right here is going to be 3 over z. Okay, the second one is b over z plus 5. b was negative 3, so that's going to be negative 3 over z plus 5. Then the last one is c over z minus 1. c was 1, so that's 1 over z minus 1 like that. And then that integral right there is a very easy integral to do. Okay, you should be able to just pretty much write the answer to this integral in your head. Okay, that would be my hope. Okay, tell me what the integral of 3 over z is. 3 ln absolute value z. Don't forget the absolute value. Okay, what's the next one? Minus 3. You have a constant, so that's minus 3. Then you have ln of z plus 5. Okay, and then the last one is plus 1, or ln z minus 1 plus c like that. And then that's not, you need to always put your logarithms together, but that's the integral right there. See, all that partial fraction decomposition did was it allowed us to break this up into 3 parts, and then the integrals are easy. Okay? Now, if we're going to put this all together, here's what we want to do. You want to bring the 3 up. You're just now using basic properties of logarithms. Then you would have minus ln z plus 5 to the third. And then this would be ln z minus 1 like that plus c. So now you got to put all that stuff together. Well, the way this goes is like this. It's just college algebra stuff. How do you put together the first 2 logs if there's a minus? A quotient, right? A difference. Okay, you got to remember that and review that. So that would be ln of z to the third over z plus 5 to the third like that. So we'd have that. Okay. Then we would still have plus ln of z minus 1 plus c like that. Okay, how do you put the plus together into one log? Product, right? Okay. So when you do this now, what you would have is you would have ln z to the third, z minus 1, all over z plus 5 to the third, and you could do that. And then you could write the answer that way. Probably the best way to write this answer is, since these 2 things right here already have a third power, you could make that whole thing to a third power if you wanted to. So the best way to me to write this answer would just be ln of z over z plus 5 to the third, and then times z minus 1 plus c like that. Okay? Now, there's something about the last problem I want to see if you guys notice. Okay, that's an odd exponent. Okay? You don't know what z is. So you would have to leave the absolute value there because that's an odd exponent. Okay? You would have to. What if that was even? Then you'd be okay with just using parentheses, because if it's an even exponent, that's going to make that quantity positive, okay, unless the case where z is 0. Same thing here, that's a odd exponent, so that would be it. That's your answer, okay? A lot of work, isn't it? It's not hard. There's a lot of work in this. Now I want to show you one thing, and I will kind of do the problem this way a little bit more when the opportunity arises, but I want to go to just kind of point your attention to this stage right here. Just this whole thing right here, just kind of in that factored form. And I want to show you something on this, okay? One thing that you can do on this, and I'm going to erase a couple of things here, and this is an alternative approach to this. Sometimes this is a nice thing to do. Okay, I want to show you what happens if z is equal to 1 on this problem. Because what you can do on this, if z is 1, let me show you what happens. If z is 1, what would happen to this whole thing right here? Wouldn't that whole thing just cancel? Because 1 minus 1 is 0, right? Boom, it would cancel. If z is 1, what would happen to this? The whole thing would cancel, okay? So what you'd be left with is this piece, and then you could go through and see if you could set that equal to something. So let me show you how that would work. Sometimes it's easier to do part of the problem this way. So if z was equal to 1, that would cross that out and it would cross that out. So what you'd be left with, and you could replace all of the z's with 1, so you'd have 1 squared plus 20 times 1 minus 15, and then over here you would have z times 1 times 1 plus 5. And that equation right there has one unknown, so you could find c that way. So this would be 20 minus 15 is 5. This would end up being, have I got that right? No, I don't have that right. I'm doing my arithmetic wrong. That's 6, isn't it? So that whole thing there is 6. That's 6c. c is 1. That's what we found, right? That's another way to do it. Now you could go back, see, and you could do this problem this way. Now, if you look back at this place that I got in red, what if z was equal to negative 5? Now, there's a reason why I'm picking z equals negative 5. What would happen? What would happen to this whole thing right here? That would go to 0. What would happen to this whole thing here? It would go to 0. So you'd be left with this equals this. And you can do the same thing. So you can do that, take advantage of that when the time arises. So if z was 5, and I'll go back to this place I've got right here, this line right here, you would have negative 5 to the second plus 20 times negative 5 minus 15. Okay, everything with a 5 in it would cross out, so you'd be left with this middle part. So that would be b times negative 5 times negative 5 minus 1. Now you can solve that equation. So let's see, that would be 25 minus 100 minus 15. This side right here would be negative 6 times negative 5. I think that would be 30b, if I'm doing that right. And let's see, that would be negative 90 if you put that together. Then if you divide it by 30, you get b equals negative 3. Okay, and I think that's what we had, wasn't it? Yeah, we got b as negative 3. You see what I mean by that? So if that arises, you can bypass the system of equations and often do it that way. And then the last thing that you could do is, if you want to find the last variable, now just let z be 0. If z is 0, that cancels, then you're left with that. So you can do the same thing. Does that make any sense? Okay, so if something's in a factored form, you can either go ahead and multiply everything out and set up a system, or you can take advantage of what I just showed you. Okay?
And how are you getting, like, z equals 1? Is that just if you're getting
it's because I'm observing that if it's 1, that will cancel out. I want that to happen. So the z equals 1 comes from there.
Okay.
That will cause that to cancel and that to cancel. Then the z equals negative 5. Why did I pick negative 5? because that would cancel.
So you just pick whatever value.
Whatever makes something cancel. See, like if you let z equal 0,
Right.
that'll make that cancel, it'll make that cancel. So if you take that approach, then you don't have to work out the system of equations. And it just sort of depends on the situation. These problems like here that have several terms, you can do it that way. Okay. All right, so we got everything on that. Let's go to the next type of thing we're going to look at. And there's 3 types of these things you got to look at. So the next thing I want to look at is the repeated linear factor. And the repeated linear factor kind of goes like this. This would be if something's repeated. And let's just write down one example on this to kind of give you an idea. Let's say that you had 1 over, let's say, z plus 1 to the third, just as an example of how you would set that up with partial fractions. Now what you have is you have a repeated factor. That z plus 1 is repeated 3 times. Okay, so you have to set it up in a totally different way that I did the simple linear factors. You got to go like this. You got to go a over z plus 1. Then you got to go b over z plus 1 to the second. Then you got to go c over z plus 1 to the third. So anytime that a factor is repeated, you have to break it up like that. And you could have combinations in these problems of some simple linear factors and some repeated linear factors. So they have to be set up like that. If that was a higher power, like a 10th power, well, then it would just go on forever with that pattern, say. Okay? So you're going to have that, you're going to encounter that sometimes as you're putting together these problems. Okay? All right, let's go ahead and look at one problem like this to start with. So what I'm going to do on this one is you need to factor an x squared out of the bottom there. That's got a common factor of x squared, so you want to take that out. So you'd have x squared times x plus 1 times dx like that. Okay. And then what we need to do is we need to get this thing set up. Okay, so it's going to go like this. When we set this up, and I'm going to worry about the integral until the very end. Let's just focus on how this sets up. Okay. Here's what you have. This is a repeated factor. And then this right here is not repeated. That's what we call a simple linear factor. So this has kind of got a combination like this. So when you set this thing up, you want to set this up like this. Okay, first thing you want to do, kind of spread out your work a little bit. And what we're going to say is we're going to say a over x, like that. Then we have to say b over x squared. The repeated factor has to be set up like that. Then the linear factor, you just say plus c over x plus 1. You only write it once. So that's the first thing you have to get straight in your mind, is anytime one of your factors repeats, you have to set it up like that. Okay, does that make sense to everybody? Okay, one of them's linear, the other one's repeated, so it must be set up that way. Okay, if you don't do it, you'll get into kind of a mess when you're doing your problem. Okay, now what we're going to do is we're going to get rid of our fractions, so we're going to multiply everything by x squared, x plus 1, to get rid of the fraction. Okay, and what all that's going to do is cancel it out, and then that's going to leave us with the ability to set up a system of equations which would allow us to figure out what A, B, and C are. Okay, and we may be able to use that trick that I showed you on the last problem too. Let's find out. Okay, so let's say if I cancel stuff out, I got the x squareds canceling. On that, over here I've got one of the x's canceling out, so it leaves you an x there. Here the x squareds cancel, and over here it looks like the x plus 1's cancel. So let's write down kind of carefully what we're left over with here. Okay, so it looks like I'm left with a 2 equals, and it looks like I have an ax times x plus 1. Then I have a plus b times x plus 1. Then I have a plus c, and it looks like I have an x squared like that. Now, there's two approaches you could take on this problem now. Okay, so first thing I want to show you is I'm going to kind of break this up into two ways here. I'm going to go ahead and multiply this out. So I'm going to have, and again, what you want to try to do, you want to try to do as much of this in your head as you can. I'm going to multiply this out. That's ax squared plus ax plus bx plus b plus cx squared, like that. And then just kind of group everything together. So we're going to group together the x squareds. So if we do that, you're going to have x squared times a plus c. Those go together. Then you have the x's that go together. So that's x times a plus b. And then you've got the leftover b like that. Okay? All right. Let me make sure everybody's kind of got the hang of what I'm doing there. The cancellation shouldn't be a problem, or the factoring. So what I'm doing is just, okay, factor out x squared, you have a plus c. Factor out x, you have a plus b, and the leftover b. Does that make sense? Okay, tell me. I don't know. Okay. Now, let's look at this. Now, you got this is what I want to make sure that you're solid on. See, this is a constant, so it might help you to see this. You don't have to do this, but it might help you to see this. Is if you wrote this part out like this as 0x squared plus 0x. Okay. So, what does a plus c have to be equal to in this problem? 0. Good. Okay, what does a plus b have to be equal to? So you're equating coefficients. Okay, what does b have to be equal to? 2, which is kind of cool. We already got b. Okay, so that means that what we would have here is we would have this system. A plus c equals 0. A plus b equals 0. And then we have b equals 2 like that. Okay, and that will be a real simple thing to work out then. Okay, like that. Okay, so we got b is 2. Well, what I would do is I would just go with this equation. I have a plus b is equal to 0. So if b is 2, what does a have to be? Negative 2. You can do that in your head. So a is negative 2, like that. And then we got to find c. So we have the equation a plus c equals 0. If a is negative 2, then what is c? C is 2. That was a real simple thing to solve. Okay, like that. Now, the other thing I wanted to show you on this now is if you looked at this like this, now those are our coefficients, but you could also go like this. If you let x be 0, let me show you what would happen. In this statement right here, if you let x equal 0, and again, you want to just do this in your head, you really do. Okay, if x is 0, what happens to this whole thing? Cancels. What happens to that whole thing? Cancels. So what are you left with? 2 equals b times 0 plus 1. We got b is equal to 2. Okay, what if you let x equals negative 1? That cancels, right? That cancels. Then you would be able to find c and so forth like that. So you can go that route if you want to. Sometimes it's easier to do it that way. So again, if you had x is 0, you would end up having this equation. 2 is equal to b times 0 plus 1, so that would just be b is 2, just like we already got. If you let x be negative 1, then the equation would become 2 equals c times negative 1 squared, so that would give c is equal to 2. Now then you can find b with one of those equations, okay? All right, so here's what we do now to do the calculus and get this integral done. So we're looking at this thing right here, okay? We know a, b, and c, so now we're going to put together and we're going to do our integral like this. So we are doing the integral of a over x, okay? A is negative 2, so we have negative 2 over x dx. I'm going to break this one up into 3 integrals, but you can do this in your head. The second integral, you have b over x squared. B is 2, so that would be the integral of 2 over x squared dx. And then the third integral is c over x plus 1, with c being 2. So those things right there are all very easy integrals to do. Each one of them is. So the thing on this is this integral right here is what? Negative 2 ln of x, right? Now this one right here is not an ln. This one is really the integral of 2x to the negative 2. So that's a power rule, isn't it? Okay, so if you do the power rule on that, you're going to get 2x to the negative 1 over negative 1. So that's going to be negative 2. I'll just write that as negative 2 over x like that. Okay, so that integral is going to come down to give you minus 2 over x. And then the last integral is another logarithm integral. So that's going to be 2 natural logarithm x plus 1 plus c like that. Okay, and then we want to put the logarithms together. All right, does that make sense to everybody? Now that's a repeated factor, so the setup's a little bit different on that. Now what I'm going to do with this, I'm just going to put these two logarithms together. You can do this in your head. I'm going to write it like this. I'm going to just do this like this. I've got 2 ln x plus 1 minus 2 ln of x minus 2 over x plus c. And then these things are going to go together. You can actually factor the 2 out of that. And then that would leave you ln x plus 1 minus ln x. Like that. So how do you put these two logs together? Like a quotient, right? So you would have 2 ln. These things go together. And then you could just have x plus 1 over x, like that. And then minus 2 over x plus c, like that. That would be one way to write the answer. It would be like that. Okay. So that should be good. You factor the 2 out of the ln's and then write that as a quotient, then you should have a good answer on that problem. So that is how you handle repeated linear factors.
So further up at the top, just for a question.
Say it again.
Further up at the top, where you were doing the setup, if it had been like x to the third, would we have had a plus like c over x to the third?
Yeah, you have a over x, b over x squared, c over x to the third.
And then it would have been the plus.
And then you would still have
over
the plus d. Okay, that'd be kind of a mess, but it'd be doable. That's kind of the idea. Okay, so what do you guys think of partial fractions? It's not that bad. It is a lot of work, but it's not that bad. At least the nice thing about partial fractions is when you get to the end, the integrals are simple. There are going to be times when maybe one of them has to be done with u substitution, but that'll help you a little bit.